D, W, E, what is that? Some random images. That's an image of a C, then an image of a bee and flower and gently, and then a cup of tea. Oh my god, that is Divisibility Rule. Hello, I am Anshul and welcome to this video of divisibility, divisibility, divisibility rule. By the end of this video, you will be able to tell if 324718 will be divisible by 4 or 7 or 9 or by 11. I mean, what's the big deal? Rule number 1. How to tell if a random number, let's say 324718, is divisible by 2 or not? Check for the last digit. If last digit is even, or in other words, if last digit is divisible by 2, then the number is also divisible by 2. Here we have 8 as the last digit. That is even. So the number is divisible by 2. For divisibility by 4, check last 2 digits if they are divisible by 4 or not. Here we have 18 as the last 2 digits. And as 18 is not completely divisible by 4, we can say 324718 will also be indivisible by 4. For 2 to the power 3, you might have guessed by now, check last 3 digits, that is 718. Check if 718 is divisible by 8 or not, which I guess you should not do in the first place because we just checked that this number was not divisible by 4. And 8 has a 4 in it. 8 is 4 into 2. जो 4 से divide नहीं हुआ वो 8 से क्या होगा? But you got the logic, right? This pattern will go on. So to check divisibility of a number by 2 to the power n, check its last n digits. If they are divisible by 2 to the power n or not. Now why does this work? This checking the last n digits, why does it work? Let's take a number 2156 and check its divisibility by 4. Can I expand it and write it as 2 into 1000 plus 1 into 100 plus 5 into 10 plus 6? Now here the thousands place and the hundreds place will always be divisible by 4. Why? Because they have 1000 and 100 that are divisible by 4. Now only numbers we have to worry about are 5 into 10 plus 6. That is tens place and the units place. That is the reason we only check the last 2 digits while dividing by 4. Even if there was some different random number, situation will still remain same. When dividing by 8, thousands place will always be divisible by 8 as 1000 is divisible by 8. Now we'll have to check the last 3 digits in that case. And this was the logic behind it. Now one very important concept. With this method, you can also calculate remainders. Just do the same thing that we did to check for divisibility. For example, if you want to calculate the remainder when 72347 is divided by 8, just go for the last 3 digits. Rule of 8, right? Divide 347 by 8. Whatever is the remainder here will be the remainder for the actual number. So 347 by 8 is 8 4s are 32, 8 3s are 24 and 3 remains. That means 72347 by 8, remainder will be 3. Let's move on to rule of 5. Same funda will apply for divisibility of a number by 5. Just check the last digit. For 25, check last 2 digits of the number, if they divide by 25 or not. In the same way, for 5 to the power 3, go for last 3 digits. And for 5 to the power n, yes, you might have guessed by now, check for last n digits. Same rule, nothing new. So will 3247375 be completely divisible by 125 or not? Well, The question you should ask is, will 375 be completely divisible by 125 or not? Yes, it is divisible. So this number is also divisible. For remainder also, we'll do the same thing. 1347 is not divisible by 25, as last two digits 47 is not divisible. And on dividing, the remainder will be 47 by 25, that is 25 ones are 25, and 47 minus 25, that will be 22. So in actual division, 1347 by 25, the remainder will also be 22. Okay. Now rule for 3. Add the digits and see if sum is divisible by 3. Same rule applies for 9 too. Let's check it for a few numbers. We'll divide these numbers by 3 first and then 9. 546. Sum of digits is 15. 5 plus 4 plus 6, 15. Now 15 is divisible by 3. So 546 will also be divisible by 3. Let's check for 9. 15 is not divisible by 9. So 546 will also be non-divisible by 9. What about 3792591? The digit sum is 379 and 2 plus 5 plus 1, that is 36. Now either we can check directly for 36 or we can take it a step further and add these digits again. 3 plus 6, 36. Add these digits again. 3 plus 6 is 9. Now we can check for 9. Is 9 divisible by 3? Yes, it is divisible. So this big number will also be divisible by 3. 9 is also divisible by 9. So this number will also be divisible by 9. So here while adding the digits, we got 36. The sum was 36. The digit sum was 36. We again added 3 plus 6 and got 9. Now this one digit obtained after repetitively adding the digits is called digital root of the number. Got it? Digital root of the number. And as we are math lovers, let's go deeper and see why this rule works. 546 is 5 into 100 plus 4 into 10 plus 6. I have just expanded 546. Now this could be written as 5 into 99 plus 1. 100 is 99 plus 1. Plus 4 into 9 plus 1 plus 6. Open these brackets and this could be written as 5 into 99 plus 5 plus 4 into 9 plus 4 plus 6. This is nothing but 5 into 99 plus 4 into 9 plus 5 plus 4 plus 6. I have just rearranged them. Now divide by 3 or divide by 9. These terms will get completely divided as they have 99 and 9 in them. All you have to check for is 5 plus 4 plus 6. That is the digit sum of the number. Got it? One more thing here. Same logic for remainder calculation. What you did to check divisibility, do the same to get remainders. 546 by 9. The digital root is 15. 1 plus 5, 6. The digital root is 6. The remainder will be same as what we get on dividing 6 by 9. That is 6 only. The remainder is 6 only. Rule for 7. Double the last digit and subtract the doubled value from the remaining number. And keep on doing that. 36925. Double of last digit, that is 5 into 2 is 10. Now the remaining digits are 3692 minus 10 is 3682. Again, last digit is 2, double of that is 4. 368 minus 4 is 364. Again, we'll repeat this process. 36 minus 4 into 2, that is 36 minus 8, 28. Now as 28 is divisible by 7, 36925 is also divisible by 7. Now this method is called osculator or seed number method. There is a different seed value for different numbers, and that value is used to multiply with the last digit, and depending on the rule we either add or subtract the final value. And what? You don't like it? Well, I don't like it either. In fact, you are never going to use it. This I can promise you. 99% chances you will never going to use it. Rule for 11. Check if sum of odd places minus sum of even places is divisible by 11. Important thing here is to start from right. On the odd places, we have 9, 7 and 1. So that will be 9 plus 7 plus 1, 17. On even places, we have 5, 8 and 4. That will be 5 plus 8 plus 4, that is 17 again. 17 minus 17 is 0. Is 0 divisible by 11? Yes, every number divides 0. So the number 418759 is also divisible by 11. Again, same logic for remainder calculation. Let's say we have a number 91735 divided by 11. Sum of odd places is 5 plus 7 plus 9, that is 21. Minus even places is 3 plus 1, that is 4. We got 17. And 17 by 11, remainder is 11 ones are 11 and the remainder is 6. So on dividing 91735, the remainder will be 6 only. Now there is one more rule for 7, 11 and 13. And it's a good one. Split the digits of the number in groups of 3 starting from units place. Add the alternate groups and then find their differences. What I mean is, here split the groups. A plus C is 481 plus 523, that will be 1004. B plus D is 765 plus 8, that is 773. Now take the difference, 1004 minus 773, that is 231. Now is 231 divisible by 7, 11 or 13? Yes, this number is divisible by 7 and by 11, but not by 13. So directly we can conclude that the bigger number will also be divisible by 7 and by 11 and not by 13. And as we are talking about 7, 11, 13, keep one more thing in mind, that there's just a small thing, that 7 into 11 into 13 is 1001. This is something which might come out handy in difficult times. Like for example, you have 3003 in division somewhere and you need to reduce the fraction. And you see that 3003 is nothing but 3 into 1001. And you immediately recall that you know something about 1001. That there is one 7 and a 11 and a 13 hidden there in the denominator. Now this is easy, I guess, right? So that's it for this video. Thank you for watching.